To analyze and assess pilot response to bird strikes, it is necessary to look at the text in the remarks field within each report. Often, in current practice, this means a lot of reading. In-Spire is a tool designed to visualize unstructured text, helping to focus the analysis on the text you're interested in and lower the overall amount of reading. We used In-Spire to examine pilot response to bird strikes using reports from a Boeing safety database. An example of one of these reports is shown here and contains a remarks field, event ID, date, aircraft model, airline name, location, damage description, region, phase, and altitude. Those fields were selected from the database because they are the ones of most interest for this analysis. After importing 1,087 bird strike records into In-Spire, one of the initial views is the galaxy view. Here, each of our records is represented by a single dot. Documents cluster together based on similarity that is calculated from word frequencies and co-occurrences. You'll notice there are 3 words printed above some of the clusters. Those are the words that contribute most to that cluster. Just glancing at the words above clusters gives you an idea of what is going on in your dataset and the language being used. I'll remind you that we haven't actually read any documents yet, but we've already learned something. A theme view in In-Spire shows clusters on a terrain map, using height to represent more documents within a cluster. Because of our powerful visual system, we can easily identify the highest peaks, and therefore the densest clusters. This tool will not, and does not claim to, remove the human from the analysis. Interaction with In-Spire is key, and there's a significant amount of cleaning that must occur. Take, for example, the cluster with birds printed above it. We already know that all the records in the dataset are about bird strikes, so this word doesn't really tell us anything. By removing birds to the outliers, In-Spire will rearrange the documents based on the next most important word. As you can see, the distribution of clusters has changed, and we now have new words above the clusters. As I mentioned, we were interested in looking at pilot response, particularly when pilot response was incorrect. In order to find strikes where the pilot had a chance to respond, we needed to isolate records that were detectable in flight, as opposed to later on during maintenance checks. Pilots use sensory terms to describe what they notice on a flight deck, terms like saw, heard, or smelled a bird. We began with a list of sensory words in a query, using the asterisk as a wildcard to capture different tenses of those words. This query generated 380 records out of our 1,087 using words like sound, noise, hum, stall, odor, and rumble. Those records are then highlighted in green in the galaxy view. Moving the other 707 documents to the outlier bin and then updating our view gives us a summary of only our searched records. The word vibration occurs quite frequently, and as it turns out is used very often when there is a bird strike. Returning to the query and adding VIBR star will capture additional documents that use words like vibrate, vibrates, vibration, etc. Querying again reveals 440 documents, and added 60 from before. This iterative process of querying and interacting with the visualization continued until we were satisfied that we had most all of the detectable strikes. A similar process was carried out for types of responses such as air turnback, diversions, in-flight shutdown, and rejected takeoff. Using the Groups tool, we can see that there are 138 rejected takeoffs in the dataset and 356 air turnbacks. If I select all of the rejected takeoffs, I am shown 138 out of 138. However, the power of the Groups tool comes from the overlap feature. Out of the 138, I can see that 59 were detectable bird strikes and 41 were ICAS model planes. Opening the aircraft models folder, I can see how many of each plane had an RTO. By selecting both RTO and detectable, and then clicking the overlap, I have selected only those records that were detectable strikes and RTOs. At this point, we had narrowed our search significantly, and reading the actual reports began. Assessing whether the pilot made the correct response requires a subject matter expert and analysis of the remarks field. We were then able to group together correct and incorrect responses for further analysis. In-Spire has a nice highlighting feature and will highlight words you choose in order to draw attention to the most relevant parts of the text. This tool minimized reading significantly by helping to drill down to those records that were of the highest importance. We never read all 1,087 reports, nor did we need to. This is often the case with large data sets, and improving efficiency can be aided by visual analytic tools and methods, such as those used here. The results of this analysis will help to inform flight training manuals, as well as determine whether airplanes are providing enough information for pilots to respond to strikes when they occur.